Here we go. We have a question: maximum absolute sum of any subarray. So you have given a array. The absolute sum of a subarray is from L to R, and consider every number. Then taking the summation of all the values between L to R and taking absolute to it. We need to return the maximum absolute sum of the subarray. So absolute means if element is negative, it will become positive. If element is positive, it stay as positive. So in this is the maximum subarray. This is the maximum subarray whose absolute whose absolute is maximum. Yeah, whose absolute sum is maximum. Then if I take this subarray, the summation will be -1. The summation will be -1. Then if I take absolute, it will become 1, which is less. So this is the largest one. And in this, if I take this, so the summation will become 0. Okay, then if I take this single, the summation will be 3 only. Then if I take this, the summation will become -8. Then we will do absolute, so it will become +8. That's all about this problem. Now let's build the approach. Let's take any test case. So let's start it. So let's suppose I am taking this test case: 1 minus 2 and 4 minus 7, 9 minus 12, 32. And we need to find uh, the greatest or the maximum absolute sum. So it can be any subarray. So the brute force will be to consider every subarray starting from 11, starting from 11, starting from -2. So if I take this subarray to create all the subarray, it will do the work to create or print all subarray. It will do the work in order of n cube, and then we will find the summation. So it will be order of n cube, but we can optimize it. The optimization. So let's talk about the optimization. So if I get this, we know the summation is 11. Then if I get this, so I will just do -2, we got 9. Then if I get the next number, we got 4, which is greater. Then if I get this, I will just do this, so it will be order of n square. So we have done the work in order of n square, but this is not acceptable. We have to do it in order of n. So I will tell two approaches. First, let's talk about approach 1. So what we need to do, we need to find the maximum absolute sum. So let's break down the problem. We need to find maximum sum. To find the maximum subarray sum, we're gonna use Cadena algorithm. Okay, but we missed the absolute part. Okay, let's first talk about this, then we will come on to absolute part. So we're gonna apply Cadena algorithm. First we got current is 11. Our answer is 11. Then we got here, we got 9, which is less. Then we got 13 is greatest. Then we got -7. So -7, it will be 6. Okay, so 6 and 13, which is 13 is more. Then 6 plus 9 will be 15. So I will update it. Then we get this, so we got 3. Then we got 35. So the answer is 35. Now let's add more elements to it. 32 minus 100, 1 2 minus 7 8. So if I add this, so it will be 35 minus 100, which is 65, minus 65. But we will just till here we got 65, till here we got 65 minus 65. So what cadence algorithm does, it restart. So we got 0 and we are restarting. Okay, so then we got 1, then we got 3, which is smaller than this, then we got 3 minus 7, which is minus 4. So our current, if our current becomes negative, we restart our current. So our current becomes 0, then our current becomes 8, and this is the largest value that we have found. Okay, but let's talk about the next test case. Let's take the test case. From the question itself, we have 2 minus 5 1 minus 4 3 and minus 2. So I have taken this example and we're gonna apply cadence algorithm. We have current is 2 and our answer is 2 now. Then 2 minus 5, which is minus 3, which is negative. So current will restart in cadence algorithm and our answer will be 2, which is maximum. Then we have 1, but our answer stays 2. Then we have minus 3. So 1 minus 3, which is minus 3, which is negative. So current restarts and it will become 0. Then we have 3, so it will be 3, okay, which is greater, so answer will update. Then 3 minus 2, which is 1, so it will be 1. But this is not the answer. Our answer is in negative, then we are taking absolute. So we need to do one more step. We need to take the absolute. So we need to reverse the signs. So positive will become negative, negative will become positive, and this. So this is inversing sign. Then we again apply cadence algorithm. So so our current will become minus 2, which is negative. So we restart. Then we have 5, then we have 4, and I forgot my answer. Answer is 5. So then we have 4, then we have 8. Our answer is 8 now. Then we have minus 3, which is 5. Then we have 2, which is 7. So our answer is 8, which is greatest. So either can answer be found in positive signs or the negative signs. So this will be my first approach. Now let's implement it. So we have current and we have answer. So then we are applying cadence algorithm. So current will be maximum between current or 0. So this is restart. This will restart if our current becomes negative, and our answer is the maximum value between this and this. Then we are inversing the signs. And signs will change. Then we again gonna apply cadence algorithm. So current will restart and we can simply copy paste this code. Just return the answer, and that's all. I hope it will work. And we don't know n, so n will be num's length. Let's submit it. And yes, we have solved this question. Then its time complexity is order of n, space complexity is order of n. And let's talk about the second approach. So approach 2. What is approach 2? So let's take the input example itself. Yes, so this is the input example. So we need to find the largest, or we need to find the maximum absolute sum of a subarray, sum of a subarray. What is subarray? uh, subarray subarray means an array from I to j, and we need to find the maximum absolute summation. So let's ignore the maximum absolute part. We need to find the summation of a subarray. What is the summation of a subarray from I to j? From I to j we can write it like this: summation of j minus prefix of j minus prefix of I, isn't it? Yes. So let's suppose this is my okay, so let's suppose this is my prefix. Let's start from starting. So this is the prefix. So prefix obviously starts from 0 index. So this is my prefix till j. Okay, so this is my prefix till j, and yes, so this is my prefix till jth index, and if I subtract my prefix from ith index, we got the summation of this subarray. Summation of this subarray. I hope you already know this concept: prefix j minus prefix I. So what is the prefix j? We want prefix j to be the maximum value of any subarray, and we want prefix I to be the minimum value of any subarray, isn't it? Yes. So let's first find the prefix. So we have test case 2 minus 5, 1 minus 4, and then we have 3 and minus 2. So prefix, so I am building prefix. This is my ARR, then prefix, so it will be minus 3, then minus 2, then minus 7, so then minus 7, and then we have minus 4, then we have minus 6. I hope this is minus 6. So let's first add the negatives. The negatives will be minus 11, and the positive is plus 6, so which is minus 5. I think there's a calculation mistake, so let me first correct it. So I found the mistake. This is wrong. So 2 and minus 6, and it will be minus 3, then it is minus 5. So there was a calculation mistake before, and this is my prefix array. So this is my maximum absolute sum, we already know. So this is my prefix till j, this is my prefix till I. So prefix till j is minus 6, and prefix till I is minus 2, which is minus 8. So from this prefix, if I subtract this, so we got the summation of this, which is minus 8. So it is as simple as that. So what is the maximum value that we are getting? The maximum value, so what is the maximum value that we are getting? The maximum value between all this prefix is 2, and what is the minimum value between all this prefix, which is minus 6. So if I do like this, the maximum minus minimum, which is 2, maximum is my minus 2, then if I do minimum, so then we got 8, which is my maximum absolute, so which is my maximum absolute. So this algorithm will calculate the maximum prefix, subtract the minimum prefix. So if there's an opposite case, so in this our minimum is more and our maximum is less, so it will do the calculation, but there's a negative sign, so negative will cancel out negative, and it will give me positive sign, positive result. So that's how this approach will work. let's code this. So one thing we want is a maximum prefix, another thing is minimum prefix, and we also need current nums. So this is my current, and our minimum will be minimum between minimum and so our minimum will be minimum and minimum. So the minimum will calculate the minimum between minimum prefix and current, and will also calculate maximum will also calculate the maximum between maximum prefix and current. Then just do the calculation by maximum minus minimum. So this approach will do the work, and yes, so let's submit it. Then let's talk about time and space complexity. So in this, the time complexity is order of n, space complexity is order of n. Time is order of n, space is constant. In both the approaches, space is constant. I will provide the code of both the solution in the description box. Thank you all for watching this video.